Let's discuss the question number 26 from test 4. This is from theory of machines, the gears part. Okay, so a fixed gear which has 200 teeth is in mesh with another gear having 50 teeth. So a gear is there which is in mesh with another gear, but the first gear is fixed. Okay, and this is in mesh with another gear, and so this, let's call this as the sun and this is a planet, and because the gears are connected by an arm, so this is the arm. So the sun gear has 200 teeth and the planet gear has 50 teeth. Okay, the number of turns made by the smaller gear, now because the smaller gear is obviously the planet, because the radius, the pitch radius varies proportional to your number of teeth. Okay, so many of the books it is denoted by T, some books it is denoted by Z. I am denoting here by N. So because radius, the pitch circle radius is proportional to your number of teeth. So 200 teeth is higher than 50, so the sun gear has to be bigger in size, the radius has to be bigger in size, the planet. So that's why I have drawn in this way. Now what is asked is the number of turns which are made by smaller gear for one revolution of arm about the center of the bigger gear. Okay, so a typical way to solve these planetary gear problems is, let us draw a table writing targeting the speeds of arm, sun and the planet. Okay, now arm, say the typical way is, what we do is, first arm we keep it as stationary, so it has 0 rpm, and now the sun, if the sun gear rotates by x, then how much the planet gear rotates. So x is basically the rpm of the sun gear, then how much is the planet gear rpm. Now two gears which are in mesh, then if you have n1 and n2 is their rpms. Okay, so let me just denote this by teeth as ts, because it will be confused, that symbol n we are using for speed, so let's denote it by t. So n1 and n2 are two the speeds, rpms, revolutions per minute, of these two gears which are in mesh. So then n1 is related to the teeth by n1 t1 is equal to n2 t2. n1 t1 is equal to n2 t2. Okay, so let's see how I arrived at. Okay, let's not directly put this relation. Let's see how do I arrive at this relation. So we have that the pitch circle speed v is equal to r omega. Okay, so that is nothing but r1 omega 1 for first gear. Now the pitch line velocity here, it will be same, so r1 omega 1 has to be equal to r2 omega 2. So let me write down in terms of speed. So r1 n1 is equal to r2 n2. Now r, as I say, it can be written in terms of teeth as r is equal to mt, so I can write t1 n1 is equal to t2 n2. So n1 by n2, okay, or in fact n2 can be written as t1 n1 by t2. This is important because now we are going to use this relation. So this is what I have written is not correct. This is the way, whenever you forget you can derive it. Okay, so now when arm is 0, arm is not rotating, arm is fixed, and sun gear rotates by x rpm, the planet gear will basically rotate with x into the number of teeth by this formula. Yeah, 1 is the sun gear and 2 denotes planet gear. So x into number of teeth of the sun by number of teeth of the planet, 50. And because if sun gear rotates clockwise, the planet gear will be rotating anti-clockwise if the arm is fixed. So that's why I have putting a minus. Now I give y revolution to arm, so that is basically added y throughout. Okay, so this is my total revolutions. So total, after giving total revolutions after giving y revolutions of arm. So these are my total revolutions. Okay, Okay, now coming to the fact that sun gear is fixed. So x plus y is equal to 0. And also what is said is one revolution of arm. So one revolution means, say my the RPM of arm is 1, so that is given as 1 RPM. So now using this relation I get x as -1, and now let's substitute x and y in the planet gear. So it comes out to be 1 minus of -1 into 200 by 50, which is 4. So this is 5. So for one revolution of arm, which is y, my planet has 5 revolutions per minute. So let's look at the options. So the answer is D. Thank you.